Hey everyone! In this video, we're going to continue on with lesson 5, which is more rational equations. So this is a continuation of what we did with lesson 4, which was our previous lesson. So I'm just going to take a minute and kind of go through here. So that being said, with this warm-up activity, I want you to find the LCD for each rational equation. So take a quick moment, pause your video here, and try A, B, and C. You're just trying to find the least common denominator that's present here. When you're ready, after you think you've got it, then come back and press play. Okay, welcome back. So you'll now see here that we've got the LCDs thrown in for us. So if I just go through that quick, in A, remember that any number that's there, like a 5, we know we could divide it by a 1 and it would still remain 5, but just give it a denominator in that sense. But x and x plus 7, there's no way to combine them without multiplying them by each other to get that LCD. So for A, we're going to have x and 7 plus x as the factors there, so making up that LCD. In part B, we see an x plus 6 and an x minus 6 definitely present. And you could do one of two things. You could throw in that -1 in there and leave it as one of my factors for the LCD. But if I multiply it by top and bottom with that -1, then I'll get a positive 2x, and I'll just switch around that x minus 6 just to make my LCD a little smaller, just to make it a little bit more convenient for myself. And then in the last one, C, I notice that I have x minus 1 and x plus 8. So then I also have this x squared plus 7x minus 8. I do recommend factor everything first. We always try to go to factoring first, because when I factor that denominator all the way to the right, we get x plus 8 and x minus 1, which are the two factors that are shown as my denominators there. So we know we would just multiply by the opposite in that case. So my LCD in this case would be x plus 8 and x minus 1. So all I'm going to do for these first three are just continue the practice that we were doing in the previous lesson. We're solving each rational equation, and we're looking for extraneous solutions. So just the same way as we did in the previous section for that warm-up, our LCD is going to be p minus 5 and p plus 3. So I've got p plus 3 twice in the denominator. I got p minus 5 once. So remember, I'm just going to zoom in here. I'm multiplying both the numerator and the denominator by that term that is missing here. I'm going to do the same, but this time I'll have p minus 5. Okay, so once I get a quick peek at that, we get our ideas all together. And remember, I can rewrite this. So when I go to rewrite this in this case, I'm going to look at all my numerators and my denominators here. So remember, for this first part, 3p is distributing to both pieces there. So I'm going to look at a 3p squared plus a 9p and remember now that is going to be over p plus 3 and p minus 5. It doesn't matter the order in which you write that in there. We're going to subtract. In this case, we have in the next term 2p, and we have minus 10 as that numerator in this case. Still with my p plus 3 and p minus 5 as my denominator. And it's going to equal p squared minus 5p as my numerator with a p plus 3 and a p minus 5. Now remember, we're not simplifying in this case. Since we are not simplifying, I do not need my denominator. So I do not need my denominator in this case. One thing I want to be careful about is this particular numerator, because now everything else is just going to drop down. We get this 3p squared plus 9p. And we're going to have this, remember, negative should distribute to both parts. Negative 2p plus 10. And we know it is equal to a p squared minus 5p. So now we're just a matter of combining like terms, bring everything to one side if we can. So if I'm looking here, I know I've got 3p squared plus 7p plus 10 equals p squared minus 5p. Remember, we're going to add and subtract, so I'm going to subtract the p squared from both sides. It's going to cancel on my right side. We'll get 2p squared. I'm also going to add that 5p from one side to the other, which is going to get me a 12p plus 10 equals 0. So now we're going to attempt to do our factoring in this case. I can factor out a 2, so now I'm looking at a p squared plus 6p plus 5. And I can do my AM method. So when I do that AM method there, I get 2 times p plus 5 and p plus 1. My AM means 5 and 1 multiply to 5. They add up to a 6. And remember, now you're setting each of those factors equal to 0, but we know 2 cannot equal 0. So my two factors of p are going to be negative 5 and p equals negative 1. Now, remember, these are my solutions as of right now. You still need to make sure you're doing a quick check. So with that quick check, I want to make sure I get no extraneous solutions. So if that was the case, I look back at it here. I want to make sure that none of these could go into my denominator to cause a problem for us. I can either plug into the LCD. I can plug into the factors individually in this case. It's really up to you of what you want to do in that case here. But when I'm thinking of it, when I check for my extraneous solutions, I do my quick thought that, hey, negative 5 minus 5 is okay. That's going to get me a negative 10. Not a 0 on the bottom, so we're okay. Negative 5 plus 3, negative 2, so negative 5 checks out. Same thing with negative 1. Negative 1 minus 5 equals a negative 6. Negative 1 plus 3 is a 2. None of those, that got me a 0 in the denominator, so these both are good. They are both my solutions for this. We've checked them for extraneous. I'm good to go. All right, and the next one while I'm here. For 2, my LCD, remember, is going to be x times x plus 3. So that being said, I know I'm going to be multiplying by an x plus 3 for the left fraction. And I'll multiply by an x in the middle and by an x on the right side. Now, it's up to you if you want to write it out like I did in the previous step, you can. I like to cheat the system a little bit. I clearly can see I got x plus 3 and x all on my denominator, so I'm done with those at the moment. I'm thinking, hey, those are not things I'm worried about right now. I've got the 2 from the original with that x plus 3. We've got a minus 3x. Remember, I times that by x. And it was equal to x times that x here. So that's all what my numerator would look like in this case. So that's my numerator at the moment. I can distribute now, so I'll get 2x plus 6 minus a 3x squared equal to an x squared. Again, we want to make sure we bring everything to like terms in this case. Now, that being said, I'm going to minus this x squared over. And in that same step, what I'm going to do to make my life a little bit nicer is I'm going to rewrite this in standard form. So I will have a negative 4x squared plus 2x plus 6 equals 0, which so far makes sense. We're all good with that. I'm going to pull out a negative 2 as a GCF there to get 2x squared plus x plus 3. Now, since I'm solving, I could just divide out that negative 2 right here. So I could also just divide everything. Zero divided by anything, still 0. And then when I'm in this case here, when I'm looking, I'm going to go ahead and do my headphones trick. 2 times 3 we know is 6. But in this case, with that 2 times 3 being 6, I'm trying to think if anything could add up to a 1, but it looks like I've got all positives in this case here. I'm just going to double check in there. Whoops. If I look back a second, actually, if I divided everything by a negative 2, bear with me, I'm going to rewind this step 1 second. If I pulled out that negative 2 over here, both of these signs have to change. Sorry about that. So I just changed those signs. That's going to cancel out. So I should be looking at 2x squared minus x minus 3. Quick fix there. Sorry about that. I figured once I realized I couldn't factor, I realized I had a little mistake on my hands. So I just wanted to fix that quick. So now I have to multiply to a negative 6, which makes more sense because then I could split this up into a negative 3x and a positive 2x. I'll bring down that 2x squared and that minus 3. We're still equal to 0 over here. This is where I like to do this grouping here. I'll pull out an x and get 2x minus 3. I'll pull out a 1 to remain with a 2x minus 3 over here. And my factor is going to be x plus 1 times 2x minus 3. So remember my two solutions then are x equals a negative 1 and x equals a 3 over 2. And if that's the case, I'm going to do a quick peek. But both those being the case, neither of my denominators are affected by it, right? If I have x, the only thing that could affect that is if there was a 0 in one of my answers, which I don't have. The only thing that's going to cancel out here is if I had a negative 3. So in this case, I do my check. Negative 1 and 3/2 are my two solutions in that case. All right, one more time in number 3. So remember, I'm still going to recommend that for number 3, what I would do in a case like this is first I would factor. I'd factor that denominator over here, x minus 4 and x plus 3. Those multiply to a negative 12, add up to a negative 1. So I know those are my factors when I do my AM method over here. Now, I see the x plus 3 in the first one, which is nice because then I know I'm only missing a x minus 4 over here. Now I run into a tiny snag here because I know that this 4 minus x, in this case, if I want it to be x minus 4, what I need to do is multiply by a -1. And whatever I do to the bottom, I'm going to do to the top. And then I'm going to deal with that piece first. So that's going to turn this -3 into a +3. From there, what I want to look at is now I still have that x minus 3, plus 3 that I'd multiply on the top and the bottom there. So that being said, in this case, we got my LCD. When I try to put all these pieces together, we had 2 in the original. We have this x minus 4. I did that double negative to make a +3. And we're going to times it by the x plus 3. And we're going to keep it equal to 2x minus 2. As long as your denominators match, like I have x minus 4 and x plus 3 in each of those three, I don't need it at the moment. 2x minus 8 plus 3x plus 9 equal to a 2x minus 2. I've got a 5x plus 1 equal to a 2x minus 2. I'll subtract the 2x from both sides. I'll get 3x. We'll subtract 1 from both sides equal to a -3. X is going to equal a -1 over here, which, again, doesn't ever, if I plug it in, will not make my denominator equal to 0. So as long as my denominator doesn't equal 0, I could show the check if I'd like. -1 minus 4 is a -5. -1 plus 3 is a +2. Neither equal 0. Even if you plugged it into the x squared minus x minus 12, still not getting a 0 in that case. Then with 4, what is the solution set of the equation here? So again, just like in the last one, let's just factor this first. I'm going to have an x and an x minus 2, meaning I'm going to multiply the middle term by an x minus 2, and I'm going to multiply the right term by an x. If that's the case, the 10 is staying strong, plus 4 times that x minus 2 equal to that 5 times x. I get 10 plus 4x subtract 8 equal to a 5x. I know I get 4x plus 2 equals 5x. And I subtract the 4x from both sides. 2 is equal to x. Now remember, if I were to plug that in though, 2 minus 2 is equal to 0. So we reject this answer. We reject it. It's no good. So that's got to be choice 4. Remember, this is the empty set. So that's an empty set. It means there's no solution. It's not the same as a 0 because 0 can be an answer to something. So that empty set means no solution in that case. Okay, last question. A little bit of a big one from the Regents here. So we've got Sarah who is fighting a sinus infection. Her doctor prescribed a nasal spray and an antibiotic to fight the infection. The active ingredients in milligrams remaining in the bloodstream from the nasal spray, N of T, and the antibiotic, A of T, are modeled in the functions below, where T is the time in hours since the medications were taken. Sarah's doctor told her to take both drugs at the same time. Determine algebraically the number of hours after the medications were both taking the medications when both medications will have the same amount of active ingredients remaining in the bloodstream. So first thing is to not overthink about this. Have the same amount. So when I see you have the same amount, I know these should be equal to each other. So that's exactly what I'm going to do. I'm going to have t plus 1 over t plus 5 plus 18 over t squared plus 8t plus 15. It's equal to 9 over t plus 3. Because after I get through that first part of recognizing what it wants me to do, then it's the same thing of everything we've been doing here. So if I factor that middle piece first, I should end up with t plus 5, t plus 3, which makes sense because if I look at my left denominator and my right denominator, I know I'm just missing the t plus 3 over on the left. On the right, I'm missing the t plus 5. Now my denominators match. All three denominators have the same thing. Remember now, I'm going to distribute everything for that numerator in the left piece. I'm going to get t squared plus 1t plus 3t plus 3 for that first one. Then I got a plus an 18. We didn't multiply anything in the middle. Equal to 9t plus 45. Now I'm going to take that and start combining my like terms. I get t squared. I get the 1 and the 3 in this case to get plus 4t plus 21 equal to 9t plus 45. Remember that I am subtracting the 9t from both sides, so I get a negative 5t. I'm also subtracting the 45 from both sides, so when I take 21 minus a 45, I'm going to end up with a negative 24. These do factor nicely for me with the AM method. I'm going to get t minus 8, t plus 3, multiplies to a negative 24, adds up to a negative 5. So t equals 8, t equals negative 3. Now, in this case, when I think about it just by thought alone, ask yourself, can you have a negative time? Absolutely not. So I already have a feeling that I'm going to reject this negative 3 since it's going to be negative 3 hours later of this medication. But in here, if I plug that in, right? If I plug in negative 3 plus 3, I get a 0. That's no good. So that's why this one's out. I could double check the 8. The 8 will work because if I plug it into either, 8 plus 5, 13 is fine. 8 plus 3, 11. Both not 0, both just fine. 8 hours is when those two things will equal each other. All right, so hopefully this video helps clarify anything you have. Remember, you can always pause, rewatch, do anything you need with it. We're going to keep continuing practicing this in class further, but thank you for watching.